As part of a computer science field, you must know the answer of these upcoming questions that I will ask. And some of them they might look silly, but trust me, they are essential for you to become a programmer. So the first question and the absolute beginner question is, what is a computer? So if I come to you and ask you, can you define the terms that make a thing a computer? We call it a computer. Can you do that? Well, according to my knowledge, I can specify a computer as a device that can process and store data. But let's take a look at one of the definitions that I found over the internet, which I found this one is very, very important. A computer is an electronic device for storing and processing data. I'm going to read this first and then come back and emphasize on each of these parts. So it is an electronic device for storing and processing data, typically in binary form, according to instructions given to it in a variable program. Cool. Now let's come back and analyze each one of these parts of this definition. So the first part is said, an electronic device. What do we understand from that? So we understand that this computer that has some hardware, some physical items. So it's an electronic device that contains some wires, some electronics devices. This device is used for storing, we store information, and processing data. Now that leads us to another question. What is data? Well, data can be image, can be video, can be a spreadsheet, Excel spreadsheet, or can be an email, right? So all this data can be stored on a computer, typically in a binary form. Now, what is binary form? We'll come to that later. But binary word, it means two. It means, one of them, either true or false, on or off, 0 or 1. We will come to the binary concept in a while. And then let's continue. According to instructions given to it in a verbal program. Well, that's a very interesting part of this definition. According to instructions given. So that means a machine cannot do anything unless you tell it what to do, right? So the person who tells a machine what to do, we call him a programmer, right? These instructions normally given in a programming language that we will define later. This program is defining the set of actions that normally this machine must do. For instance, you clicked on Microsoft Word or you clicked on your Google Chrome icon. The computer must understand that this action needs to do a specific sequence of actions. Open the Chrome, load the previous open tabs, if any, probably visit the Google page as the home page, and so on and so forth. So those actions are predefined for you when you click on Google Chrome icon on your laptop. So according to this diagram, we can call a machine a computer if it has a processor and one of the rest. For example, a storage, memory, or input-output. So by doing this, or by analyzing this definition, we can say a computer can be your own laptop, personal laptop, or a desktop, or something else, right? So let's take a few examples of what is a computer. So a mobile has a lot of processors inside that. And generally speaking, it has trillions of transistors. If you don't know what a transistor, I advise you to Google it. But basically, your mobile is also a computer. Your microphone, this microphone that I'm speaking to, it has a built-in computer. It processes the signal and digitally filter it and analyze it and sending it to the computer. Your car engine, CCTV, your cameras in your building or in your company. Your ATM machine when you withdraw money or you deposit money. This ATM machine itself, it has several computers inside it. Your smartwatch, your Xbox for gaming, servers, Now, servers, I put it there because I will come back to it and explain what do we mean by servers. But stick with me. For now, servers is just a computer, normal computer that we normally see and use. And according to the definition of the computer, and according to this diagram, a computer might has a processor, memory, storage, and input-output. So input-output examples can be speaker, printer, microphone. So those are input-output devices connected to your main computer. All right. Now, what else can be a computer? Is this a computer? Yes. I built this 2 years ago. It is an 8-bit computer that has all the essential components to be called computer. It has a clock, it has a memory, it has a memory address register, it has an input-output, which is the display at the top. It has all the components, most of the components that your laptop has, and yes, we call it a computer. It's an 8-bit computer in the early of 70 or 80. I built this to know the details of a computer actually, and what do we mean by RAM, what do we mean by bus, all that stuff. So I advise you to check out the channel that I recommend, which is on YouTube, that you can you will watch and learn how to build this computer by yourself. Now, if you come and see this, we have these switches, the red boxes that I can switch and input data to it, right? So this data is binary. What do we mean by binary? As I said earlier, binary is a statement that can be on or off. You see here at the top of this bus, we have few LEDs. We have 8 LEDs. Since it's an 8-bit computer, it has 8-bit or 8 LEDs in the bus. So when I enter data to be, for example, 1100, 1100, that data presented as electrical signal in the bus, and that's what we call it binary. So computers normally don't know what is 0 and 1, but it knows that 0 represent, or we know actually, 0 represent the LED, or that line, this line is connected through it, is off. There's no electrical signal, and that's what we call it false or 0. All right, so if the LED is on, that represent the other statement, which is true or on. So again, binary is a word that represents two states, either on or off, true or false, 0 or 1. Cool. Now, if we go a little bit here and we understand what is a computer, that leads us to another question. These computers normally operate with a specific instructions predefined for us, right? So for example, you plug in your printer and you type Control P to print that, and the paper comes out from your printer. How does that happen actually? So I'm sure you asked that question before, and let me tell you the answer here. This internal behavior of your machine doing something that you normally don't do it, or you don't program it or code it, is something done previously by other people, by other programmers, those who build the operating system. So the operating system, from its name, it's operating and controlling the behavior of the system, of the machine. So when you plug in a printer and you press on print, the operating system will know how to send this data to the printer. You don't know how that happened, or you don't need to know how that happened. So the operating system will take care of the hefty-lifty details of the connection between the devices, the connection between the bus and the RAM internally in the system, and all that stuff. Now, that leads us to another interesting question. What is a programming language? So according to the definition before, when we said a program or a computer is an electronic device for storing and processing data, and then we said typically in a binary form, according to instructions given to it by who? By a programmer, given to it in a variable program. What do you mean by a variable program? So if I told you what is the meaning of software, the keyword software, or what is the difference between software and hardware? Well, software consists of two words, soft and ware. Ware means a product. Soft is soft, right? So when we say hardware, it's hard product, all right? So hard product means we cannot change it. We cannot change its shape unless we reinvent it. For example, take a look at this iPhone or this phone. Since or once this item produced from the factory, we cannot change it. We cannot change the color unless we produce another one. That's why we call it hardware. When we talk about software, it means that it is a product, but we can change it without changing the hardware, right? And that is what a program, what we mean by variable program. Variable program means it can change. And the powerful behind this change allows us to create billions of applications that we normally use in our daily life. For example, your Google Chrome, your Microsoft Word, Microsoft PowerPoint, all these are variable programs coded and programmed by other programmers to perform a set of actions that we need as a human. For instance, you go to Microsoft Word and you start typing. So that's what we need. This program is designed to understand the input from your keyboard and present that on your screen. And ultimately, we want to save it somewhere in the storage system or in the storage area. Now, let's continue here to this question, come back to this. So we know that programming language is a set of instructions given to the machine to perform a specific action. So going back to the same computer that I built, which is 8-bit computer, and if I told you to build with it a calculator, simple calculator that adds two numbers. So if you open that in your phone and you go to the calculator, one of the functionalities in this calculator to sum two numbers, right? So the mathematical equations for this is to be x equal 3, for instance, y equal 4, and z equal x plus y, which leaves us to be 7. Now, when we take these instructions from a high-level perspective, and we assume or we believe in it that this set of instructions will be translated somewhere into the machine code, which is the binary 0 and 1. So by definition, these instructions is defining the program. And the programming language itself is a way of writing the program in different shapes. So you can write the same program using binary, using 0, 1, or using Python, which is the high-level program that presented on the screen. So let me verify that with you. If I open Python on my machine, and then I say, well, x equal 4, y equal 3, and then z equal x plus 4, the same equations I printed over the slides. Now if I say, give me the value of z, print z, it is 7. So with this program, internally, a lot of instructions happen to the machine to store this data at the first stage, to store this data, and then to perform the action, which is the submission, or the addition, or the subtraction if you want. So Z here in this case is a set of instruction that tells a machine to perform the add or sum operation on these two numbers, and then we use print function to print the value. Now, again, as I said, the programming language, you can write this simple calculator in any language. You can write it in binary or in Python. Now, if we want to know the difference between the Python and the machine language, which is the binary, let's understand first, or let's walk through this example. So again, here it can be like the first line might be 11010010, maybe something like that in the machine. Maybe y equal 4, it's something like this, 11011101. So which is easier for you as a human, to write this one and zeros or writing it in Python? Of course in Python. So that's why we invented programming languages. So the last line might be something else, like 10111000, okay? And this 0 and 1, we call it binary again. Now, if we come back to this interesting question, what is the difference between modern programming languages and binary language, which is the machine language? So if we put this as a diagram, the binary language will be at the low level. And normally no one, does it now, actually. So before, in the 70s or 60s, developers used to write code in binary, 0 and 1. Or, if you go back to this, it's switching this switch up and down. That's a tedious process if you want to do it right now. Now, what we are doing is something very modern and very high level. According to the languages we have right now, we have Python, we have Java, PHP, C++. All of these languages considered as modern programming languages that allows us to write high-level language instead of writing it in 0 and 1. Now, you might ask me this question: what is this assembly in the middle? Assembly language is invented after the binary and it was like the starting point of any other language, actually. It was fast and it's really, near to the binary. It was very difficult to write, and I experienced this myself when I was in college. I did one long program in assembly to control a robot, and it was, very, very difficult. If I want to do it in Python, it won't take me, I think, just few lines, 7-10 lines maximum. But back then, it took around 200 lines to perform the same action, the same, problem that I want to solve. And if I want to do it in binary, that will take even more. So again, the same example here. In Python could be x equal 4, y equal 3, z equal x plus y. So Python is, by definition, it's a programming language similar to the binary, which is the machine language. And in between, we have this assembly, which is no longer used, I guess, by modern developers, but it's used in embedded system. So if you want to write that code in binary, you will write this bunch of zeros and one. Can you do that? Of course not. Can you do it in assembly? Well, yeah, but you will face a lot of difficulties and a lot of headache writing it. Look at Python or Java or JavaScript. Those languages are designed for us, human, to write code easily and then let the machine translate it to the binary. All right? So how this translation happen behind the scene when we write Python language, for example, or JavaScript? How that transition or translation process from Python to binary code, because ultimately it will go to the binary shape. How is that possible? Well, let me introduce you to a new topic, which is called interpreter versus compiler. A compiler, from its name, it's compile or translate whatever you wrote in the high-level language to the lowest level possible, which is the binary. So a compiler will take your code, for example, from C++, and then translate it into binary zeros and ones, and then insert it into the CPU to be processed. Cool. What is interpreter? Well, interpreter is the same thing. It does compile or translate your code from your high-level language, for example, Python, into the lowest level language is the binary. However, what is the main difference or the major difference between compiler and interpreter? If you used C++ before, if not, it's okay. If you used C++ or Java or C#, those are languages based on compiler, or the compilation method is done by a compiler. Whereas other languages such as PHP, JavaScript, it uses interpreter to execute the language or to execute the statements of the language. The major difference is that, for example, you wrote a specific program in C++ and then you add a mistake, a small mistake. That mistake, even if just one letter, will fail the entire program. So the compiler will not translate your code to the machine code unless you fix it. All right, so if you have 100 lines and you have an error at the 100 line, then if you run the program, it will not run from the beginning. In interpreter, it is somehow different of how it executes the lines of your program. So for example, you are writing a program in Python. Let's come back to this. So we have x equal 4, y equal 3, z equal x plus y, and then probably here you add some dumb mistake that make the program fail. Well, Does that affect anything? No. Anything period this line will be executed. So the interpreter will work line by line. It will go the first line. If it's okay, it will execute it and then go to the next one, and so on and so forth. And when it fails, when it comes to the line of failure, it will stop. And that's the difference. That's the main difference between interpreter and compiler.